Find the depth to steel, D, in inches. In this problem, a concrete beam is doubly reinforced with number 10 sized rebar, which is supported by number 4 sized rebar stirrups. The base and width of the beam are provided, as well as the cover and spacing between tension rebar, where the rebar diameter for M is equal to the diameter of the longitudinal reinforcing bars of steel. The depth to tension steel for the entire beam, D, equals the average of the depth to tension steel for each layer of tension steel weighted by the area of steel in each layer. For this equation, we'll define layers of tension steel 1 and 2, as shown. If we look up the areas of different size rebar, we identify number 10 sized reinforcing steel has a cross-sectional area of 1.27 inches squared per bar. Therefore, we can compute the area of tension steel for layer 1 and layer 2, which equal 2.54 inches squared and 5.08 inches squared, respectively. Plugging in these values for area AS1 and area AS2, all we have left to determine is the depth to tension steel for layers 1 and 2. Using the figure, we can identify these depths as measured from the top of the beam. If we focus in on one corner of the cross-section, we can easier define D1 and D2, where depth D2 equals the beam width minus the cover minus the stirrup diameter minus half the diameter of the longitudinal steel. From the problem statement, we know the height of the beam and the concrete cover. We can look up the diameter for the number 4 and number 10 size rebar in a standard table. From that table, we extract the values of 0.500 inches and 1.270 inches for these two diameters. Plugging in all the variables, the depth to the second row of tension steel equals 43.865 inches. The depth to the first row of tension steel equals the height of the beam minus the cover minus the number 4 rebar diameter minus M minus 1.5 times the number 10 rebar diameter. We recall M is equal to the longitudinal rebar diameter. We can substitute this value into our equation and simplify. As before, we know the height of the beam and concrete cover. And we also know the diameter of the number 4 rebar and number 10 rebar. Solving for D1, we get D1 equals 41.325 inches. Finally, we plug in the values for variables D1, D2, area of steel 1, and area of steel 2. The depth of steel, D, equals 43.02 inches. When reviewing the possible solutions, the answer is C.